I thought it would be interesting to get a quick look at the relationship in our little model, the books written by authors. So we'll do a bit of work with that to get a taste of it before we dig into relationships more deeply later in the course. I've modified the program file with two new methods, add author with book and get authors with books. So we'll add a new author with their books as opposed to adding books to some of the existing authors. The first three lines of code here have nothing to do with EF Core. I'm simply working with the author and book classes. I've created yet another author called Julie Lerman, and we'll definitely deal with this duplication later. Then I added two of the Entity Framework books I wrote oh so long ago to this author's books property. Next is some familiar code. I'm instantiating the pub context again, and then adding this author. Notice that I'm not telling the context anything about the books. I'm just passing in the author object that has the books already attached. Then I call Save Changes again. EF Core will take care of inserting the new author and the new books and make sure that in the database they're connected by way of the author's ID that the database will generate. So EF Core comprehends the relationship between them and knows how to relay that to the database. The second new method gives you a glimpse of retrieving related data. Instead of just asking for the list of authors, I'm using this method called include, which is a method of dbset. In order to use the include method, you will need a using statement for Microsoft.Entity Framework Core, then passing into it the books property of the author's class. In case this syntax with the equal sign and greater than sign are new to you, the full expression with the A, that symbol, and then a.books is referred to as a lambda expression. And you'll be seeing plenty of these throughout this course. In the case of the include method, it's saying for each of the authors that you find, also bring back their books. So the resulting authors list will have the books attached to each of the authors. I then iterate through each author that came back in the list, write out their name, and then iterate through any books that are attached to that author and write out their titles. When I run the app, you can see that the first two authors don't have any books, which is correct. We didn't add any to those authors. But the third does have the two books listed under it. Checking the database, there are all three authors now. Notice that the ID for the new one is 3. When I open the books table, the two books are listed, and not only did they get their own primary key values from the database, but notice that the author ID is 3 for both of them. I mentioned earlier that EF Core has a convention for any property named ID, and it assumes that that's the database primary key. There's another convention that identifies properties that should be keys, and that's a property that has the name of the type plus ID. So book ID followed that convention, and EF Core knew that it should be the key for the book type. Therefore, it let the database generate those keys just like it did for the authors. And once it created the new author, then EF Core took the newly generated ID, 3, and inserted the books into the database along with that author ID. There's plenty more to learn, which is why you're watching this course, but you're also seeing that at its simplest, EF Core 6 is already taking care of a lot of effort in interacting with the database that I am very happy not to have to code up myself. You learned about the proper development environment for building applications that will be using EF Core 6. Then you learned a bit about the EF Core APIs and providers and created a very simple model with a DB context-based class that's aware of the types you want to persist. Finally, you got to see EF Core 6 in action in a very minimal way, inserting and reading authors, then authors with books. In the next module, we'll dig further into querying your database with Entity Framework Core. Before wrapping up this module, here are some resources that I've mentioned along the way, and a few others that I think you might find useful. I'm Julie Lerman, and thanks for watching Entity Framework Core Fundamentals. Hello, this is Julie Lerman. Welcome back to Entity Framework Core Fundamentals. In the previous module, you got a quick look at querying some data and performing some very simple updates. This module will focus more on querying the data using EF Core in your applications. We'll start with some basics on what EF Core is doing for you when you create and execute a query. So we'll look at the query workflow from link to the database and its results. Then you'll learn a little more about using LINQ to express and execute queries and learn about filtering, sorting, and even aggregating data with queries. It's important to understand what EF Core is sending to the database. EF Core does have some really cool logging capabilities, which are extremely useful. But we'll learn that a bit later on in the course. And for now, just take advantage of the SQL Server Profiler to check out what EF Core is creating and sending to the database. Finally, I'll make sure you're aware of an important aspect of query performance related to whether or not you need EF Core to keep track of the state of objects that were retrieved in a query. So let's get started. You can learn a lot about the basics of querying by revisiting the getAuthors method from the previous module. This performed a simple LINQ query to retrieve all the authors from the database. Before we get started, I want to point out a notable change in the program file in this module. Since I'm depending on the database that I created and populated in the previous module, I've removed the ensure created logic from the top of the file. That way, EF Core won't even waste time looking to see if the database exists. I'm going to focus on the most basic form of a query in order to help you understand what's going on when Entity Framework performs queries, and provide you with a little more insight that's very useful to understand. Remember that this toList method is what triggers EF Core to go ahead and execute the query. Even as a beginner, it's important to understand the workflow of EF Core's queries. When a query is executed, EF Core first transforms the query into proper SQL. It takes a few very fast passes in memory to do that. Internally, EF Core does cache queries and reuses them to avoid repeating that effort for that application instance. Then EF Core opens the connection using the connection string and provider information and executes the SQL command in the database. I'll put a breakpoint after the query, run it, and here in SQL Profiler, you can see the query that was executed in the database. Don't worry about using SQL Profiler for now if you're not familiar with it. I'll show you a much easier way to log right from EF Core a little later. So just watch the SQL that I'm showing you here. And for you real newbies, this is T-SQL, SQL Server's flavor of SQL. And it's just selecting all of the columns from all of the rows of the authors table in the database. The results come back from the database as rows and columns of data. And just as EF Core was able to translate an object into a SQL insert statement, it's also able to translate those rows and columns of data back into the relevant objects. We refer to this as materializing the results. And back at the breakpoint, you can see those results in the authors variable. Authors is a list of author types, and it has 3 author objects. Each one of those has the first name, last name, and ID populated from the database. I didn't ask for books in the query, so the books property will be empty for every author object here, even those that do have books in the database. All of this effort has been orchestrated by the DB context, and by default, the context has one more task to perform: keeping track of the objects that were returned by the query. The way it does that is to create an instance of this little tracking type that's part of the EF Core APIs, and that object has a reference back to the resulting object. So for example, we'll have 3 of these tracking objects, and each one will have a reference back to each of those 3 authors. Additionally, it keeps track of some state information and other details. We'll learn a lot more about tracking and saving in the next module, but the fact that the context starts tracking by default is relevant to the performance lesson at the end of this module, so we'll return to that shortly. There are 2 ways to express queries with LINQ. One is using the LINQ methods that I'm using, and the other is using LINQ query syntax with operators. The LINQ query syntax looks more like a SQL statement, except you still have to use an execution method at the end. I prefer the methods, and I really haven't used the operator syntax in years, so you won't see much of it here. But there are plenty of developers who do use the operators, and I wanted to be sure you were aware of that. You'll be able to learn more about the LINQ operator syntax in the Pluralsight course, Querying Data in EF Core. Queries are composable, so you don't have to express the entire query in one go. You can break them apart if you have a complicated expression to work out or even to defer query execution. And here's an example of that where I define the query in one variable and then in another statement. I modify the query, or I can append a LINQ execution method to it. You may be wondering, where's the query? Here, I'm just specifying the DB set. And really, I'm just doing that because we haven't seen filtering, sorting, or other ways of constraining the query yet. And that's okay because I only have 3 rows in the table so far. But it's not really common to request every single row in your queries. And of course, if you have a lot of data, you'll need to be very mindful of that for performance. There's another way to trigger a query to execute besides using a LINQ execution method, and that's by enumerating the query. As soon as EF Core sees that you actually want some data when it hits the enumeration, it says, oh, wait a minute, I've got to go to the database and get that data for you. So that triggers it to execute. In that case, you don't even have to define the query variable in advance. You can just enumerate over the query itself. But there is a really important performance consideration to be aware of if you're depending on enumerations to go ahead and retrieve that data for you. At the beginning of that execution, the database connection gets open, and it will stay open until the enumeration is complete and all of the results have been streamed back. In some cases, that's perfectly fine. But in others, for example, if you start performing a lot of operations on each one of those results while you're still looping through them, not only can it cause performance problems, it could also cause other side effects if other people are interacting with that same data. Being the control freak that I am, I always prefer to just use an explicit execution method, such as toList, to get all of the results into memory, and then do whatever processing it is that I need to do on them. Your own scenario and performance testing should be able to guide you to the best workflow for your solution.